I don't read the newspapers because they all have ugly prints.
At the starting of the week at Summit Talk Show.
The horizontal curve selected for this study is located at Al-Ramin Academy near Padang Kawat. This location is very busy during peak hour since it is the main road for all type of vehicles. Now let's look into the safety audit. Although speed bump is already in place, many drivers continue to exceed the speed limit. Most vehicles do not slow down and instead accelerate immediately after passing the bump. This shows low compliance with speed control, which may be caused by the open road design, the poor positioning of the bumps, or the lack of enforcement. In terms of alignment, the layout of the horizontal curve is quite confusing. Some drivers enter and exit the corner incorrectly, and there are even cases of vehicles going into one-way road without realizing it. This happened because of insufficient signage. Installing clear directional arrows would be efficient and prevent wrong-way movements, reducing the chance of serious accident. The lighting in the area during night time is inadequate. Several street lights are broken, leaving road dark and limiting visibility for users. This condition increases the risk of accident. Finally, the road surface is uneven and unsafe. For example, the sewage tank cover is often struck by motorcycles, which could cause serious injuries. Resurfacing the road and securing tank cover would provide smoother traffic flow, reduce hazard, and improve safety for all road users.
This is a measuring wheel. Wow! Before using this equipment, make sure the digital counter is set to 0 by pressing the button. This is a radar gun. Before using this radar gun, make sure the battery is good and the display is clear. Before we start our sport speed studies, we measure approximately between 80 to 100 meter using the measuring wheel. One of the students need to set at one end and signalize the other student that placed on the other end. The radar gun works by projecting a signal toward the front grille of an oncoming vehicle to calculate its instantaneous speed. By standing as close to the line of travel as safely possible on this curve, we minimize the tracking angle to avoid cosine error, ensuring highly accurate real-time data logging in kilometers per hour. To ensure we targeted the correct vehicle over our 100-meter study zone, our procedure utilized a two-student coordination system. One student positioned themselves at the entry point of the zone to identify and track isolated, free-flowing vehicle. As soon as the targeted vehicle crossed the starting marker, this student signaled down to the road to the radar operator, ensuring a seamless tracking workflow.
Firstly, let's observe road geometry, side distance, pedestrian facility, and traffic junction. Road users from this lane have limited side distance due to the slightly highly road topography. However, a speed bump is provided to reduce the vehicle speed and improve the safety. Let's see what do we have here. We have skin resistant markings, speed bump, we have sidewalks, we also have a road signage, and in front of this road we have a street lamp. Other than that, we have another road signage and road merging to the Padang Kawat. And we also have a junction to MTDC and DATC. The road is relatively highly, especially at the junction connecting to College Anggrek, Padang Kawat, DATC and MTDC, which may affect driver visibility. Next, we focus on road user behavior, conflict point, and traffic volume. Road users were observed not using the designated sidewalk and crossing the road outside the zebra crossing area, which may pose a safety risk. A conflict point occurred at the storage waiting area. As the limited storage space located in the middle of the main road, it will affect the movement of the other vehicle and may disrupt the traffic flow.
In data analysis, we collected 50 vehicle speed data on site. The speed class interval divided by 5 categories from 15 until 39 km per hour. From raw data, we transferred to frequency distribution table. Then we determine the mean of speed class interval, which is 26 km per hour. Next, we calculate cumulative percentage to determine 85 percentile speed of the road. The cumulative frequency curve indicates an 85 percentile speed of 33 km per hour. This means that 85% of the observed vehicles travel at or below 33 km per hour. Compared with the UiTM campus speed limit of 30 km per hour, the operating speed is slightly higher by 3 km per hour. Since the study location is a T-junction with vehicle turning movements and pedestrian activity, by maintaining lower speeds is important to reduce severity of crashes. To justify the operating speed, we apply standard JKR arahan teknik jalan guidelines by stopping sight distance. By the formula, we determine reaction distance and braking distance. When the operating speed increases from 30 km per hour to 33 km per hour, the driver's reaction distance increases from 21 meter to 23.1 meter. This means the vehicle travels approximately 2.1 meter further before the driver begins braking, reducing the available time to react to unexpected hazards. The braking distance increases from 10.1 meter to 12.24 meter, an increase of 2.12 meter. This shows that even a small increase in vehicle speed requires a longer distance to bring the vehicle to a complete stop.
Next is safety precaution. Remember, always wear a safety jacket when working on or near the road. Stay at least 2 feet away from the edge of the road when conducting the road laboratory work. Remember, do not use a mobile phone and wear a earbud while conducting the laboratory work. Always ensure the measuring wheel is set to 0 before use to avoid measurement error. Always stay focused, follow safety precaution, and understand the proper operation for all apparatus before conducting.